This is our planet, what makes us happy. And the good news is that a lot of it is water, and we use it to our, I think, advantage. And that can be shown here. The sea lines of communication, we want to use them, keep on using them and keep them clean. So definitely not like this. What would I like to share with you is maybe it seems maybe a little bit boring, but it was for me quite a discovery to dive in further into the IMO ambitions as they were stated a few years ago. So what I did do, I really took the IMO ambition as it was shared with everybody and took those sentences one by one and did some calculations and did try to come up with some conclusions. I think the first one is loud and clear. 50% reduction of greenhouse gases emission in 2050. So far, loud and clear. Then the next thing the IMO ambition says is to do this through a decline of what they call carbon intensity of international shipping, which basically means reduce CO2 emissions per transport work, or basically per amount of cargo shipped. And this as an average across international shipping. And then we have the two key numbers, 40% by 2030, 70% by 2050. I was asking myself the question, what does this mean, those two numbers? Is this going to bring us the ambition as it was stated in the first line? I had my questions. In particular, if you see that those ambitions should be realized through a further application of EEDI, its next phases by likely increased percentages and appropriate to the various ship types. At the same time, it was concluded in the third greenhouse gas study, 2014, the latest one. I know that the next one is in preparation and will come out soon. They envisage shipping to grow towards 150%, 1.2% growth per year, or 350%, 3.7% per year in 2050. And actually the last percentage is the effective growth as it was over the last decade. So yes, it did grow 3.7% per year over the last 10 years. Of course, there is Corona now, but I will, let's say, come back to that. So this is what the scene was at the time when this was presented. So what kind of questions did I ask myself? I think I did actually skip one. No, not sure. I did try to investigate what the real consequences were of those ambitions. So I took two scenarios, 1.2% and 3.7%, with some estimates about how the difference in growth percentage could be per ship type, because obviously this is an average number and it's likely that container shipping will grow more and maybe tanker a little bit less. Next step I did is collected emission data from 2008 to 2020, from the greenhouse gas 2014 study, from the ICCT report 2017, and from some UNCTAD studies. And I made a small extrapolation about how this emission data further developed in the period 2017-2020, just to take 2020 as my starting year of my analysis. Focused on three ship types, container, bulk, tanker, and rest is in the category other. I assumed a lifespan of 25 years on average for a ship. And that basically gave me the possibility to calculate the average required greenhouse gas yearly reductions to 2050, where I obviously had to choose a distribution over existing ship types and new ship types, because otherwise I couldn't make the calculation. So that is what I did. I did make a rough distribution over new ships, what I have to do yearly reduction, and existing ships, what I maybe really have to do in the coming years, and then make a calculation. Here you see actually the global results of that calculation, and just to guide you through this graph of this table somewhat, I did distribute the growth percentages over the various ship types, did not take them all equal. This is the 1.2 fleet growth scenario. Lifespan 25 years for all of them. And I did then finally calculate their contribution in 2008 as it was. And I assumed those reduction percentages for container, for bulker, for tanker, for other, for new vessels and for existing vessels. And this is what you need to reach the 50%, as you see in the right-hand bottom corner. So those look like not too bad reduction percentages per year, but I will show you in a minute that it is quite challenging as it is. So this is the 1.2% outcome. I needed those reduction percentages to reach the 50% in 2050. Then looking into the 3.7% fleet growth scenario, then you see in those red box, you see the percentages needed to reach the 50% in 2050 with 3.7% fleet growth. And how do the two compare? You can actually see it here. It's on average around 3% in the 1.2% scenario, and it's about 5 plus for the 3.7. And that's all for new vessels, a little bit less for the existing vessels. This is actually my choice, this distribution. Then I show you an example what it means for the container fleet, which, as I said earlier, grows a little bit faster than the average fleet. It shows you the per ship type averaged for the given fleet growth, which has to be reached under the assumption that every ship type category has to bear its own burden. Because obviously if you are making such a calculation about percentage reduction, you have to do some assumptions, and my assumption is that every ship has to take its own burden in terms of this 50% ambition. Old and new contribute both, as was shown before, albeit a little bit different. You can obviously diverge from that assumption and say existing ships are not going to do anything. It has all to be done by new ships, but that is not my assumption. The other assumption is that, and that's a little bit different from EEDI, which just requires a percentage reduction at the start when the ship is built, and it may keep that percentage through its lifetime. But that's not what I assumed. I assumed that they have to move on with those yearly reductions every year. And that is because I think it will not be done only by design aspects, but likely also by mixing green fuels in your fuel mix. So then there is a possibility. So this is the result of what I did calculate. So again, this is not per individual ship type. Those are averaged permitted emission percentages over lifetime. And just to give you a short explanation what it says, for instance, if we take a ship built in the period 2015-2020, and we put their performance at 100%, at 100% at the start. Oh boy, I have to be careful. There you see that, I'm not going to use my cursor anymore, sorry. You see that such a ship built between 15 and 20 in the upper half of the table, container vessel, that ship should reach a reduction to 64% in 2040. If you move to the ship built 2020, 2025, it starts in the first place 15% lower, but it has to reduce to 54. And this is all about the average reduction percentages for container vessels as a whole. And that brings us in 2050 to a vessel which ultimately needs more than 60% of emission reduction in 2050. This is for the slow fleet growth. If we move to the downward half of the table, then you see that this same ship being built in 2050, or I have to say the group of ships, they have to perform with only 16% of the emitted greenhouse gases allowed. They have to reduce more than 80%. And this is all not true for the individual ship types, but this is what the total fleet average has to perform. I thought that those numbers were fairly shocking. If we now look at the carbon intensity, so really emission per transport work, so not, let's say, summarizing or summing over the whole fleet, then we have a somewhat different picture. We now use the 40-70 approach, which actually the number doesn't account for the fleet growth itself. It just looks to the individual ship. It doesn't account for fleet growth. It only uses the ship or it assumes the ship to have this percentage of carbon intensity when it's newly built. There are no requirements on further improving during its lifetime. It forget about the existing vessels, although EEXI could potentially change that. And then we find these results, and I will help to guide you through. If you look at the upper line, the upper red box, you see that in 2008, I put every emission number and also transport work, emission per transport work to 100. Then if you move to the emission per transport work in 2020, which is as it is now, you see that container vessels did a wonderful job. They already reduced to 55%. As the bulkers did, tankers did also quite well, and others did quite well. Obviously, this is basically mainly due to slow steaming and other maybe aspects of economical issues, but also reflecting some technical improvements of the vessel. So a fairly good job done. This is all based on let's say, numbers from the literature. If we now move on to the ambition, which is set to 40 reduction in 2030 for all vessels, which I just assumed, and then do the same thing for 2050, we have to go for the individual reduction of 70%. You see that with this fleet growth of 1.2%, the emissions in 2050 will not reach the 50%. It will reach 63.3, as you can see on average in the right-hand down bottom line corner. So basically the message of this one is, yes, sorry. Sorry?
No, please go ahead, Johan. We'll see the questions at the end.
Okay, good. So what you can see here is that, yes, this 40-70 approach is not going to help us, not even with a 1.2% fleet growth. So what are my conclusions? That only a fleet growth of 0.4% will meet the requirement. So if I go one sheet back, you see that this number in the right-hand down corner will then end up at 50, only when we have a fleet growth of 0.4%. Next conclusion, and when we have our fleet growth of 3.7%, then effectively the ships built, in this case container ships built in 2015, may only emit 8% as a fleet, which is almost zero emission. If we accept the 3.7 total fleet growth and keep on using the current EEDI with those 40-70 ambitions, it will lead to 130% emissions rather than 50% in 2050. And I put this all in sheets, which are available to everybody to check. I will show you in the end. Obviously, the current Corona crisis perhaps saved us by the bell, because yes, maybe it is likely that we will have only a very modest fleet growth in the coming decades. This is just a nice slide. What will Corona bring us in the energy transition? This is what a panel of 200 people gave as their opinion. They hope it will accelerate it, but it's not sure whether it will happen. And a larger percentage says, yes, it will accelerate. And then there are a few other people who are a little bit less optimistic here. Way ahead. Alternative green fuels won't be around soon. So what do we have to do? To include existing vessels, continue technical development on energy use reduction, including vessel hull propulsion design and energy converting configurations. I think in particularly the latter are very important. Hull propulsion will help us definitely with another 5 to 10%, maybe a little bit more. But then we have to look into energy converting configuration further on, like better configurations of engines, better use of engine, maybe sail assist and things like that. And finally, focus and include on operational savings, including voyage planning and energy management on board, which I think gives a somewhat better gain. Yes, my suggestion would be, maybe I'm not allowed to say it in this group, but move away from EEDI, because that is primarily a design-based approach, whereas I think we should move to an operational design approach. How can that be done? It's complex, I know, but maybe we have to agree on yearly energy budgets per vessel and use the monitoring, reporting, verification and IMO DCS to measure whether people keep their, let's say, promises and are not using more than they are allowed, given their energy budget. And finally, enable design for operation rather than design for trial, as we are now. I think this is more or less concluding my speech. There is one thing I can show you. There is an article on this with this title, and on the link you see there, you can find the article, but you also can find the Excel sheets, which give you all the details about how I did do those calculations. It gives you a lot of detailed information. Everybody can check. And I think this does finish my presentation.